notes. In this problem, a student is standing on a bridge 40 meters above the water. She's going to throw a rock with a velocity of 16 meters per second at an angle of 30 degrees above the horizontal. We're going to find how far the rock goes in the x direction before landing in the water. So first things first, we wanted to draw our picture. It's already here. We have our velocity in the x and our velocity in the y as components of the speed of the rock as the person throws it. And here we broke everything down into our x and y stuff, as we do with projectile motion. In the x direction, we know that displacement is our question mark, and we don't know the velocity in the x direction yet, but we're going to find it very soon. In the y direction, we know the displacement is negative 40 meters because it's downward. We know the acceleration is negative 9.8, and we can find the initial speed in the y direction by looking at the initial triangle of velocity that we've got. So first things first, we're going to find the velocity in the x and y direction. We're going to use a little bit of right triangle geometry to do that. So first thing, how we do this, we're going to look at the velocity in the x direction. That's the adjacent side of this triangle. So our equation would look like this. Velocity in the x direction equals the cosine of the angle, which is 30 degrees, multiplied by the velocity that the rock was thrown. When we plug in our numbers, the velocity in the x is going to be cosine of 30 degrees multiplied by 16 meters per second. And our calculator should tell us that that's a speed of 13.86 meters per second. We're going to do the same thing in the y direction, but now the y is the opposite side of our triangle. So velocity in the y is equal to the sine of the angle, which is 30 degrees. I'm just going to plug in the speed right away, which is 16 meters per second, running a little short on room. So to shorten that up a little bit, we'll just plug it into our calculator and get that the velocity in the y direction is 8 meters per second. We're going to plug those numbers in to our columns, 8 meters per second in the y, and 13.86 meters per second in the x. Now, as usual, we're going to try and figure out, well, what is it that we're looking for? We already know it's displacement in the x. So we have to find the time in order to solve for it. We typically have to go to the other dimension, like we will right now, to find the time, because we have enough stuff in the y with displacement, initial speed, and acceleration to find time. The equation that we're going to use is the third equation on our kinematics equations that we've learned, which is displacement equals initial velocity multiplied by time plus 1/2 acceleration time squared. Now this is a quadratic. The t is in two different spots, and we can't just eliminate one of the terms because our initial speed is not 0 like it is in horizontal motion. So we have to use our quadratic equation, which we learned in class, and that would be that the time is equal to the negative initial velocity plus or minus the square root of initial velocity squared plus 2 acceleration displacement divided by acceleration. When you plug all those numbers into your calculator, what you will get is that time could be one of two things. It could be 3.79 seconds, or it could be negative 2.16 seconds. Now hopefully we all know that there can only be one correct answer, and it should be pretty easy to spot which one it is. We can't have negative time, so we're just going to forget about that negative 2.16. That one doesn't make any sense. So now we're going to solve for our distance in the x direction. We have an equation for that, which is distance equals velocity multiplied by time. Plugging in our numbers, we would have the speed of 13.86 meters per second. We're going to multiply that by the time of 3.79 seconds. And when we do that, our calculator should tell us that our distance is 52.5 meters in the x direction. So, just in quick recap, we drew our picture. We then went to our x and y stuff, wrote down the numbers we knew. We had to find our x and y velocities using our right triangle geometry. We found time in the y direction using the quadratic equation, used our time to find distance by plugging into our x equation. And that's the throwing rocks problem from the notes.